Hello all. This is lesson 4 of Unit 1. We're talking about extrema and average rates of change. At the end of this lesson, you will be able to determine intervals on which the functions are increasing, constant, or decreasing. You will also find maxima and minima of functions. You will also be able to determine the average rate of change for any given function. Starting with increasing, decreasing, and constant functions. Increasing functions are those functions that have a slope upward. So when we read graphs, we read them from left to right, just like always. And when we see a slope going upward, we can tell that it's increasing. And the increasing interval is going to be, for this graph, is negative infinity to infinity. Now, if I'm looking at decreasing, you're looking at a function that is sloping downward. Okay, and again, this is on the interval of negative infinity to infinity. A constant is going to be neither increasing nor decreasing. It is a horizontal line. So let's apply this principle into a problem. We're going to use the graph of each of the functions to estimate intervals to the nearest 0.5 unit of which the function is increasing, decreasing, or constant. Support your answer numerically. So when I'm looking at this function, I can see that it is, if I'm reading it from left to right, it is sloping downward at all times. So the interval on which this is decreasing, and it is decreasing, so we're going to say decreasing on an interval from negative infinity to infinity. Now, they asked us to support this numerically, so we're going to support this numerically. Numerically, we're going to pick some points anywhere on the function and plug them into the function. So I'm going to choose negative 8, negative 6, negative 4, negative 2, 0, 2, 4, and 6. You could have chosen any values you want. I chose those values just to choose those values. Now, when I plug them in, I've got 1024, 1024, 432, 128, 16, 0, negative 16, negative 128, and negative 432. Now, as you look at this, the y's, as you're moving it from smaller x values to larger x values, you'll notice that it keeps decreasing. This is your numerical proof. This is when they ask for numerical justification or support your answer numerically, this is what you're going to put on your paper. So let's check another one. It says you use the graph to the nearest 0.5. Alright, so when looking at this, we see that the graph is increasing. And remember, we're looking at the intervals along our x-axis, so from negative infinity all the way up to negative 1, we are increasing. And then from negative 1 down to 1, we are decreasing. And then from 1 to infinity, we are all increasing again. So now we're going to have to put that into interval notation. So we are increasing from negative infinity up to negative 1. And then from negative 1 to 1, we are decreasing. And then again we start increasing again from 1 to infinity. This should be a parenthesis, I'm sorry. Okay, and now they're going to ask us, again, we have to support it numerically. So I'm going to choose some values in each interval and plug them in. So I'm going to choose some values in the negative area. So negative 13, negative 11, negative 9, negative 7, negative 5, negative 3. And when I plug these values in, I've got negative 2,158. I've got negative 1,298. Negative 702. Negative 322. Negative 110. And negative 18. We can see that it's increasing, and the y values are increasing in value, which does fit with what we said. It's increasing from between negative infinity all the way up to negative 1. So now let's check the other area. We said between negative 1 and 1. So I'm going to say negative 0.75, negative 0.5, 0, 0.5, and 0.75. When I plug these values in, I've got 1.8, 1.3, 0, negative 1.3, and negative 1.8. Again, that fits with what we were saying. The y values are decreasing. And finally, I'm going to choose values in the other side. 3, 5, 7, 9, 11, and 13. And I plug these values in. I've got 18, 110, 322, 702, 1,298, and 2,158. Again, we can see we're increasing in our values as we go along in our x's. So this is your numerical proof for your answers up here. The next concept we're going to have is about relative and absolute extrema. We've talked about relative maximum and relative minimum back in Algebra 2. A maximum is a point on the graph where we hit a crest. It's a mountaintop. Okay? A minimum is going to be a valley. It's the dip. It's the lowest point in the graph. These are your relative maximum and minimums. Okay? Now, an absolute maximum, which is this point right here, this is your absolute maximum. This is your absolute maximum because there's no other point on the graph, anywhere on the graph, that's higher than it. So it's absolutely the maximum highest point. But you have two maximum points. This one's a relative minimum, or maximum. It's relative because it's relative around the points around it. Relative minimums, we got a minimum here, a relative minimum there. The absolute minimum is going to be the absolute lowest point on the graph. So this point right here is the relative or absolute minimum. Okay, it says estimate and classify the extrema for the graph of f of x. Support your answer numerically. Now, when I look at this, you have to estimate where it is and classify it. So when I'm looking at this looks like it's about 0.5, and it's a relative maximum. I have a relative maximum at 0.5. So relative max at x equal to negative 0.5. And then right here I have a relative minimum. So I'm going to say relative minimum at x equal to 1. Now I have to support this numerically. To support this numerically, it's really quite simply, I'm going to choose a couple points right below negative 0.5, right above 0.5. Kind of like find the limit as you're approaching negative 0.5, as x approaches negative 0.5. And then I'm going to choose some points right below 1 and right above 1. What we should see is it increased and then it started decreasing. Okay, so our function here that we're looking at, f of x equals x cubed minus x squared minus x. And I'm going to choose some values, 3 here, 3 here, and what we should see is that we're going from increasing to decreasing and decreasing to increasing. So let's choose -1. Keep your numbers simple. -0.5, 0, 0.5, 1, and 1.5. So when I plug these values in, I come up with -1. I come up with 0.125, 0, -0.6, -1, and -0.4. Now, when I see this, I'm looking at this. I started at a negative, and I went to a positive, went above 0, and then I came back down to 0. So it looks like I was increasing up to that point, and then I started decreasing again. Does that fit with what a maximum is? Increasing and then decreased. Yes. So now let's take a look at this area. I was going from -0.6 to -0.1, so that's a decreasing value. It's going from -0.6 to -0.1, and then back up to -0.4. Does that fit with what we think a minimum is? It goes from decreasing to increasing. Well, yes, it does. This fits. This is your numerical support. Last thing we're going to talk about is average rate of change. Average rate of change, super simple. You've been doing it since Algebra 1. All average rate of change is slope of a line. We're going to find the slope of a line through 2 points that are on our function. Now, we're going to choose, they're going to tell us 2 points, and they're going to say find the average rate of change between those 2 points. Well, that's going to create a secant line. And that's what this is. This is a secant line. The secant line, the slope, by finding the slope of the secant line, we find the average rate of change. Hey, look at this. This is the slope formula. Remember, another name for x, f of x, is y. So, y2 minus y1 over x2 minus x1. Slope formula. Find the average rate of change of this function. Find the average rate of change of this function along this interval. 2, -2, -1. Now, I know what my x values are. I plug them in. -2 minus -1. Now, I need to find my y values. Well, those are pretty easily found. I find the y values for those by plugging in -2. So I say f of -2 equals -2 cubed plus 3 times -2. -2 cubed, well, that's -8. -8, well, that's +8. Plus -6. 8 plus -6, 2. So, f of -2 is 2. Now, I do the other one. I plug in -1. F of -1 equals -1 cubed plus 3 times -1. -1 cubed is -1. -1 is 1. Plus 3 times -1 is -3, -2. So 2 minus negative 2. 2 minus negative 2, well, that's 4. 2, negative 2 plus 1 is negative 1. So the average rate of change for this is negative 4. This you've been doing since Algebra 1. So we can keep doing it. Not that hard. Alright, so this should be enough information for you to be able to complete your work of 1-4. Now, hopefully all of you got my message over the weekend saying that I would like you to do 1-3 and 1-4 and watch them, because on Monday those are the two assignments that I'm expecting you guys to finish. You will finish 1-3 that you started on Friday, and you will be doing this one as well. This one is a fairly easy assignment. I've already looked at the homework. I think you guys could probably get it done in about 15 to 20 minutes. So that's what we're going to be doing. Thank you very much, guys, and get this stuff done. See you later.